Hello, hello, hello. Good afternoon, good morning, good etc. Good to see you all this wonderful Friday. This Friday, we are going to be exploring a little bit of a new project that I've recently come across. It's called kcli. It's super interesting, and I want to share it with you because I'm super impressed with it. Like, the person involved has done some really incredible work, and I think it's worth definitely taking a look at. But first, as usual, if you're out there, say hello. Lovely, lovely to know you have an audience when you're working on this kind of stuff. Also, let's go through our newsletter and talk about what's happening next week, which I'm super excited about. Next week is happening. It's eBPF Summit. So we're going to be doing the eBPF Summit live. It will be a remote conference. You can join us, and you can come join the Slack and come help us welcome all of our wonderful speakers. You go to eBPF.io, and you look at the top, you'll see register here. It's a free registration, and you can come and you'll be able to watch it from there. If you click on register here, it'll also show you things like the schedule, so you can see who is going to be speaking with us this year. So we have our welcome, and then we have Shweta Saraf coming to us, Mr. Thomas Graf talking about the eBPF Innovation Roadmap. We have the eBPF CTF, which if you haven't done it, is just a real blast. And the very next eCHO episode, which is coming up next Friday, is going to be a walkthrough of the eBPF Summit with its creator, Mr. Dan Finneran, who's going to be walking through like how that went and how it all went. We'll have a little break. We'll jump into more things around eBPF, right? A tale from a telecom operator. We're talking about just a number of really incredible talks, including Hemant Mala. Great to see him presenting with us again this year. Lots of really great stuff in here. So if any of these talks look interesting to you, or if this is an area that you want to get into more, oh, nice. Chris Tarazi talking about primer on eBPF map batch operations. So many great folks joining us to talk about all of this great stuff. So that'll all be happening on Wednesday of next week, and I hope that you'll be able to join us. It should be a real hoot. Hey, Joseph, good to see you. I did have a good vacation. I think you mean Memorial Day, but yeah, it was really good. All right, let's take a look at what else is happening here. Okay, so like I said, oh, and then we have the newsletter, of course. So let's go check. Let's jump into the newsletter here. Cilium.io. As always, if you're interested in subscribing to this, you can go to cilium.io/newsletter, and then you can just drop in an email address, or you can subscribe to the RSS feed, and all of that will be available to you on a pretty consistent basis. About every 2 weeks, we release a new one of these. Here is a proof that eBPF is Turing complete. Kind of funny. eBPF TLS tracing, past, future, and present. Lots of good stuff in here, talking about different mechanisms for actually tracing TLS through the stack from the kernel perspective when you're leveraging eBPF. It's really cool work, being able to actually understand what's happening at a packet level or at a network level when it comes to TLS. Building a fast firewall with Java and eBPF. Hubble network observability and security, utilizing Hubble for network observability. Looks like a Cilium blog coming out with Shedrack at the helm for this one. Pretty exciting stuff. Lots of really great information there. Learning about lessons learned from Subozu running Cilium at scale. Love to see that as a talk, actually. eBPF compiler and Go, write Go, get eBPF. Pretty cool stuff. Lots of ecosystem stuff happening. A new case study about Alibaba Cloud, how CrowdStrike tech outage reignited a battle over the heart of Microsoft systems. Parka and OpenTelemetry, two eBPF-based profilers emerging development, which I think is super exciting. I actually just saw this the other day. Polar Signals is a company that's near and dear to my heart, as it's been. The people behind it are some of the best folks I worked with at CoreOS and other places. So just an incredible team, and it's really great to see them kind of like unifying this vision between OpenTelemetry, eBPF profiler, and the Parquet agent. So super exciting stuff there. Will really, I think, really help people in the ecosystem make even more use out of that. Want to stop kernel panics? Use eBPF. eBPF for security. There's lots of really great stuff in the community about all of this stuff. And then the how-to, of course, we get into OpenTofu, RKE cluster with Cilium on Azure. We have eBPF 120 seconds. Just lots of really great stuff here. All right. Let's jump into the main topic for today, which is going to be the kcli tool. And I want to talk to you a little bit about why I think it's so neat and what it actually does. So kcli, let me go ahead and close some of these windows. And let's jump over to the docs. So this tool is meant to provide a unified user experience when interacting with the following virtualization platforms: libvirt, vSphere, KubeVirt, AWS, Azure, GCP, IBM Cloud, Overt, OpenStack, Packet, Proxmox, good Lord. And beyond handling these virtual machines, Kubernetes clusters can also be managed for the following types: kubeadm, OpenShift, OKD, which is the open source version of OpenShift, HyperShift, which is a newer technology that allows you to deploy hosted control planes on OpenShift and then to bring up other virtual machines or real machines and join to those control planes. Very cool. I'm starting to see this combination of OpenShift and HyperShift starting to be kind of out there in the market, trying to replace some of the vSphere deployments that are out there. Microshift, which is a much smaller version of OpenShift, and K3s. And then if you want to get started, it has a quick little installation method around basically just installing a libvirt hypervisor, installing the tool kcli, which is a sudo bash kind of thing. You can actually install it a few different ways. And a package installation method, and then a container install method. Lots of great tooling here. And let's jump into like how all of this works, because I have been, like I said, I've said it a couple times, I've been super impressed by how this has been working. So I kind of want to show you what that means. So let's jump in here. So I have a kind of a development box in GCP. And this is a beast of a box, right? It's got nearly a gig, 100 gigs in memory. It's got a good amount of CPU. Like there's just a ton of like, let's see, bpytop. Do I have that installed? I do not. Snap install bpytop classic. Let's do that to show kind of like what we're talking about here. If you haven't used bpytop, I definitely recommend checking it out. It's a pretty cool tool. It's also written in Python, much like kcli is. But you can see we have like 64 CPUs, lots and lots of RAM. This is just my dev box for all of this stuff. You can see that we're pretty idle at the moment. We've got 4 VMs running. And I wanted to show you kind of like what I'm doing there. So there's a ton of really cool stuff about the way that kcli operates. Let's take a look a little bit about what that is. So this is what's called a params file. And in this params file, I've got a bunch of parameters that I've defined for a cluster that I want to create, including adding applications like after install, I want to install the local storage operator, the OpenShift data foundations operator, KubeVirt hyperconverged, and multi-cluster engine. All of these things together. So part of the install process, it will just go through the whole thing and install all of this. I can give it a count of how many control planes I want. I can add extra disks. All of these things are possible. And if I do kcli list VMs, I can see that I have 4 VMs up and operating here. And they together make a cluster. If I do get nodes, I can see that I have 4 nodes up and running, and I have all of that stuff operating, which is absolutely wild to me. If I do kubectl get cluster operators, OpenShift is successfully installed and in a happy place. And if I do the CSV piece, which is basically how in OpenShift you can determine if things have been, if the add-ons have been added. So these are the add-ons that are outside of the scope of the core cluster operators. These are the operators that are being installed after the fact, right? So this is that open source OpenShift data foundation stuff. That's the multi-cluster engine, hyperconverged. You can kind of see that they're also in a succeeded state. All of those things are working. So all of this is just like an example of what's happening here. So let's kind of explore kcli a little bit more and understand what's actually happening with it, because it's kind of mind-blowing, honestly. So if I do kcli, there's a couple of different arguments that you can pass to it. Like you could actually use kcli to download things. Like you can use kcli to download a Helm image, Hypershift, kubeconfig, ISO, lots of other tools out there. I don't have pod managed all, so that's one part of it. But I could like get all of these things just by downloading them either from the cluster that I've created or a ton of other places, which I think is pretty darn cool. We can do list operations, so we can see a list of all of these things that we have created or not created. I haven't created too many of these things at the moment. What I've done really at this point is just kind of create the cluster. So if I do list cluster, I can see that OpenShift cluster that I created and the VMs associated with it. There's also info. And info is where you can get kind of the base of what all of these parameters might be. So if I do info cluster OpenShift, these are all of the default parameters for the OpenShift configuration, which is pretty awesome. And it gives you a lot of information up here at the top to describe like what's actually happening. So this will deploy an OpenShift cluster with an arbitrary number of control planes or workers using OpenShift install, and creating the nodes with nodes with kcli. So this will create those VMs for you. This allows easy tweaking of the hardware characteristics of those nodes. When running on cloud platforms, load balancer and DNS from the platform are used. Otherwise, extra static pods, core DNS with multicast DNS, Keep Alive D, and HA proxy are deployed on the nodes to provide a self-contained platform. Now, in one sentence, this really highlights an incredible amount of work that I think is definitely worth looking at. So if we do kubectl get all -n kcli infra, this is what we're talking about, right? The developer actually deployed core DNS, HA proxy, Keep Alive D, and multicast DNS, and then configured that to be used so that you could actually like interact with it. One 270019153. Absolutely wild. So yeah, like it's really very cool how this is actually a self-contained cluster and I can interact with it. If I do kubectl config view, right, I'm actually talking to this sslip.io, which is basically where it turns, it's a DNS server that turns this argument 192.168.122.254 into a hostname that we can use and implement in our certificate, etc. So just amazing to me how this all works. kcli can also create VMs, right? So you can also create a VM. And if you wanted to know how to create that VM, you could do info VM. Here's an example of what that would look like. So by default, it would use the core. It would use the RHCOS. The user would be core. The plan would be C1. The qvert, the profile would be kvert, and then the number of CPUs and amount of memory, etc. And it would actually just be able to create this VM in that way, and it'll basically assume that it's going to create the same thing again from the previous parameters that were passed. So that's a really interesting assumption there. But we can pass help, create VM dash dash help, and it'll also give us some example implementations here, right? I could pass the type of interface I want is E1000. I can change the MAC address. I can change the MTU. I can actually put in some routing configuration. I could put in the DNS reservation or DNS entry for it. All of these things are possible, and all of these things are configured like using the Python libraries for the libvirt, right? So I do first VM, yeah, first list. These are all the VMs that are running. So this is all running inside of here, and it's just so cool how he's got this all figured out. If I wanted to troubleshoot or look at the console for something, right? Okay, kcli console C1 worker what? That's the visual console, which I don't have installed. But if I do serial C1 worker 1, I'm connected to the serial console of this box, which is great for troubleshooting what's actually happening at bootstrapping time. What if I wanted to SSH in, right? SSH, and it'll handle all of that for me. I'm already SSH into the box. I have sudo access. It's copying my SSH key directly into it that I have created here in this directory, or on this host, I should say. So all of that to me is actually kind of mind-boggling, like how all of that works. Like he's just done an incredible job. Let's do kcli create cluster and then we have options, right? We can create a cluster of Hypershift, K3s, kubeadm, Microshift, RKE2, AKS, EKS. All of these are our options. So let's do generic, and we'll do help. Here's an example of how to create with the generic parameters. I can create a params file, or I can actually even just create the cluster like we see it here. So let's do this. Let's do a generic one with one control plane and 2 nodes, and just boot that up. And it will grab the latest generic cloud base image. So these params are actually all from that info, right? So if I were to do kcli info cluster generic, I'd be able to see the entire list of potential parameters that I could apply to this cluster. But for now, I'm just going to be taking the defaults. We'll take a look at what gets created. So it's bootstrapping the first MyCube control plane 0. And it's waiting for it to become accessible. If I split this and make this a little bigger again, jump into here, kcli console serial. So we can see the boot up process. So this is what I mean by the console piece of it. So we're looking at the boot up process right now, watching it get booted, and it just came up and became installed. So now, just like CloudInit, the CloudInit process is actually handling the installation of things at the moment. And we're watching on the upper side here the actual installation of all the things necessary to bring up a kubeadm cluster on this node. installing containerd, configuring it to be the default, grabbing kubeadm 131, and a bunch of the other dependencies, right? Here's all the dependencies for a kubelet. Dropping a bunch of Perl stuff in. Not sure what that's for, but we'll keep going anyway. Okay, kubelet service is enacted. Can't be reached because keep alive service is not all the way running yet. Again, creating all of this as a way of just completely self-contained clusters, pre-configured with everything. So now that's now reachable, right? Doing the kubeadm init. Looks like it's going to deploy Flannel by default, which is a interesting and older version of CNI for this, creating a bunch of persistent volumes. Okay. The kubectl get nodes. Oh, first we have to do this. So make it my cube cp dot shift. I'm basically using DRAM here to handle the mapping of the kube config, kcli, and then in your .kcli directory in your home directory, that's where all of the context is kept, right? So I'm going to take the mycube and I'm going to look for auth, the auth directory, and there's the kube config that I want. So I'll just copy that. Copy. I'll do dir env edit dot. The name of the cluster is mycube. So now kubectl get nodes. You can see we have the control plane up. And I think it's just a standalone. It doesn't actually do anything for us. If we do kcli, I thought we had more, I don't know, we had worker nodes too. List VM. We do have the other worker nodes. Looks like there's a problem. Because while we did create them, kcli, let's try this. Kcli console serial mycube worker -0. It's up kcli ssh. Kubelet's active, resets disabled. There's our kubelet configuration. Oh, so the fault is it looks like the I didn't do the slip thing. So that's what's happening. I think what's happening. So there it is putting this into the host file. So that means it should be reachable. Interesting. Let's try this. Let's do, and this is the thing I love about this, is that it's so interactive, right? So I do kcli, delete cluster, my cube, yes. And that'll wipe it out. And then we'll recreate it, but we'll do a parameter here. Goes true. Watching the boot up process. VM is accessible. And then once we get through this and we prove that this works, the next thing we're going to look at is the whole idea. Oh my gosh. You're joining. Oh my gosh. You're the person who wrote all of this stuff. Super impressed with your work. Like, welcome, Kareem. Yeah, it's incredibly cool. That is perfect. Yeah. I agree. It probably does take a little while. I was debugging it to try and see like if I was hung up on something, and it did look a little bit like there was a DNS problem, and this probably just resolves it because it uses the slip stuff. I assume that's you. I don't know for sure, but if so, super impressed with this stuff. Yeah, well, let's just get installed. We'll show how this works. And then the next thing we'll do is we'll actually also show off the Cilium integration that Kareem put into the project, which I think is really also, again, just super neat. But the other piece of it that I wanted to show before the end of the session was a Hypershift cluster working. And so because I have that OpenShift cluster already deployed, and that takes a little bit, I think it's like 17 minutes, 15 minutes, something like that to get it all deployed, but it does actually work. It just takes, oh, it doesn't look like a slip worked. So you're saying like there's a cron job or something on the worker that's actually handling the installation or the join, perhaps? Let's like that. We see our control plane is there. Ah, the SIP stuff did work. So we'll give the workers a minute to actually join and see what happens there. And then after that, we'll start playing with some other stuff. We'll start playing with the Cilium integration. but we can see as it is right now, kubectl get pods -a. This is a kubeadm cluster. It's got kubemultis deployed and kubeflannel deployed. So we're waiting for the workers to show up. Cloud.init is doing its magic. So we're not to the point where we're completely ready yet. Cloud.init is happening on this node right now. So our worker is still kind of booting up. Oh, there go the workers. There goes worker 1. There goes worker 2. The auto labeler doing its work. Control plane is ready. Workers should become ready once all the things deploy here. There we go. And now if we do kubectl get pods -a again, we can see things are running, ingress, and by default this will deploy without any changes or change, without me making any different changes. It'll deploy kubeflannel and the ingress nginx controller and multis. So multis would actually allow us to also run other CNIs if we wanted to as well. So that's overall very cool. So what else can we do? Like what else could be possible with this configuration? And this is the thing that really blows my mind, is that there's a ton of configurability that Cream has put into this project. So like, let's take a look at a little bit more stuff, right? So if I were to just wipe out that cluster again, because you can, it's super easy, delete cluster, my cube, yes. Wipes it out, cleans up after itself, super nice. Create cluster, generic, my cube, -p, slit, dash capital P, slit goes true. And then before we actually get too far here, let's do kcli info cluster generic and look at the parameters that we could pass in, right? And what I want to pass in next is I actually want to pass in some things in here around the Cilium side of things. So the SDN is the parameter I'm looking for. And SDN can be chosen between Flannel, WeaveNet, Calico, Kernel, Romana, or Cilium. Goodness gracious. So let's do SDN equals Cilium. And I believe there is also a Cilium version where you can actually specify the version of it, but I don't see it in the parameters here, but I do know that it exists. But let's just try doing SDN Cilium and see what we get. And Multis is also something you can enable or disable. Metal LB is something that you can enable or disable. And Metal LB can kind of like, obviously kind of already figure out like what load balance IPs you want to give it, etc. But this is just, it makes it very easy to bring up dynamic environments and test them. And that part is a very hard part to get right. And so I've been super impressed with what I've seen so far in this project around making it possible to do these things. It's also extensible, right? So the plans I'm using, the plans with these parameters and all of that stuff, these plans are also something that you as a consumer of this project can write or extend, right? It's just like, you know, tons of really incredible capability that is not simple work to do that really brings this project to a place where you could actually use it you could leverage it to do testing against different environments if you were developing something like Cilium, etc. Like super huge. Yeah, incredibly impressed. So let's see what the install looks like if we're going to do the Cilium install here. Now in my notes, which I think are here, I did actually also link to Cilium integration. And this is actually just a list of issues. A list of the code insertions where Cilium actually happens to pull stuff down, right? So this is where it's grabbing the Cilium CLI, the latest one. This is where it's going to be turning on the BPF file system in the underlying host or in the underlying VM. This is the blurb of text that we saw. SDN can be one of these. And then, yeah, further down. Here's how it works in Hypershift, how it works in QADM, how it works in K3S. Just super, super neat. Okay. Let's see what we saw here. Service, adding app auto labeler, kubectl, get pod -a. There we see Cilium configured and deployed. kubemultis is also there. Get nodes. And if we just SSH in, we could see that we can see that CloudInit is actually happening on that other node. So let's jump into one of the worker nodes. Let's do SSH. List VM. Oh, did I forget to set? I think I did. Yeah, I didn't set the number of worker nodes. But there's a way to solve this problem. kcli, scale, cluster, generic, mycube, workers, read. So a lot like cluster API, effectively just implemented in Python here, I can actually scale a worker node, the workers associated with the cluster after the cluster has been created. So kcli list VM, I can see those 3 workers. Let's see if that actually worked. So if I do kcli ssh mycube worker 0, wait for it to actually boot up. Oh, boot it up, and we'll do journal again. CloudInit is fired off, pulling down the Kubernetes prerequisites. pulling in Docker and containerd, doing all the things we expect it to do. Although there's no, maybe it just hasn't been laid down yet. So we'd still have to initiate a token, and I think it'll be interesting to see if that happens because I'm adding this after the control plane is already up. I suspect that's been handled, but I haven't actually tested it this way before. So let's see. Okay. Looks like we're pretty much off to the races. Yeah, 3 workers. So even though we actually created this with only a control plane, we can scale up the number of workers and add them or remove them. And it will handle all of the creation and joining the cluster, all of that stuff for us. Kubectl get pods-a. There's Cilium deploying on all of the other nodes. Just so cool. Yeah, already off the races here. And if I take a look at, so there's another thing that is possible here, which I think is really neat. If I do kcli list, there's a lot of other stuff that we can list, including looking at cluster profiles. We can look at including things like apps. So if I do kcli list apps, I can see that there are 2 different types of apps that I can list. I can list generic apps, and I can list OpenShift apps. The OpenShift apps are actually part of the OLM, or the operator lifecycle tooling that is native to OpenShift. And so again, if I look at that C1, these apps are actually pulling in operators that are part of the OpenShift operator lifecycle ecosystem and installing them as a post. Once the cluster is up, it's actually going to add these other applications in, which is very cool. But what about the other apps? What about, like, what if I do kcli list apps generic? What could that be? And here's an example of stuff that it can actually happily add to the cluster after the cluster is up, including things like Kata container, KubeVirt, Metal LB, OLM, policy as code, Rancher, Rook, and the policy as code thing I think can actually use a couple of different things. So if I did kcli, and again, just like before, right? Info, app, generic, policy as code. And then there's the parameter that I can pass. Policy as code will actually be gatekeeper. If I wanted to take a look at the parameters that I can actually pass to KubeVirt, CDI, whether CDI is true or false, and what the version of CDI is. Metal LB. It will determine a metal LB range. It will determine whether these are the parameters that you can Again, enable or disable, whether to enable metal BGP or not, right? Just tons of stuff. Like, what about the ingress piece? There's so many ingress controllers out there. What configurability do we have here? Just the ingress version. So that's probably the default one. Yeah, way cool. And then if you do that same argument against the OpenShift side, oh, it's because I need to go like that. List app OpenShift. Now, because I'm in an OpenShift cluster, it can interact with the OpenShift marketplace associated with that cluster and give me a list of all of the operators, all of the applications that I could install directly, leveraging all of these things. Wild. Just so neat how that's all wired in. And if I wanted to like look at some of the details for some of them, like let's take a look at Cube Turbo. I've never even heard of this, but let's do Cube Turbo, and we'll do info. And this is actually pulled from the project in the community operator, right? So here's the Cube Turbo namespace. Here's the CSV. Here's the description of what it is: application resource management for Kubernetes, turbonomic AI-powered application resource simultaneously optimizes performance, compliance, and cost in real time. How does it work? What does it do? And it doesn't actually provide us any parameters, and some of them don't. Right? Some of them just assume that you're just going to install it, and they'll be able to figure out how to install it or how to manage itself from there. So yeah, just significantly impressed by how all of this works. Here's our cluster up and running. Nginx is installed. All of these things are there. If I wanted to install Metal LB, kcli or kcli app, actually create app generic Metal LB help. But I want to be against the cluster that I'm pointing at, so I'm going to go into the MyCube one here. Kcli get nodes. So that's going to be my Metal LB piece. And if I do that command again, kcli create app Metal LB generic, and it will deploy Metal LB to the cluster. Yeah. Cream, I'm not sure if you're listening, but if you are, I'm curious to hear your thoughts on like adding other applications to the stack. Is that something that you're interested in as well? Because there's also some like I was also thinking about like maybe extending the Cilium implementation to go a bit further as well. But yeah, so let's take a look. The next thing I wanted to show you, now that we've done all of this, let's also take a look at Hypershift, because Hypershift is a newer technology that I think is actually worth understanding. It's out there, but I've been kind of impressed and a little surprised by how all of that works. So let's do kcli delete cluster MyCube again. Just wipe that out because we don't need it anymore. Yes. And it will happily clean up the VMs that is associated with them. Understand that I'm only just looking at cluster functionality. There's a ton of other functionality that you can use here, right? So again, kcli create you tab complete there, you can create a host, you can create a firewall, create DNS or DNS entries, you can create OpenShift, ISO, the registry, the single node operator or the single node cluster, a new repo, a web service. Like there's just a ton, including a VM snapshot, right? So like you get to a certain point, you want to snapshot the cluster, like it's all in there. Load balancing, mind-boggling the amount of work that we're talking about here. Like very, very cool. So let's jump into the next piece I wanted to show you. So I have my clusters again running here. It's my OpenShift cluster. And just like I showed you before, if I do OC get cluster operators, I can see that I have an OpenShift cluster running for 16.9. Everything's in a happy place. So if I do kubectl get CSV, gotta do that one. The CSVs are namespaced frequently. We can see that the CSVs are all in a happy place too, all succeeded. So basically we're in a place now where we can actually kind of do a crazy thing with HyperShift. Now to understand HyperShift, let's do a quick overview of what the heck I'm even talking about with HyperShift. So this is the repo for HyperShift. And this is and there's also docs, like so HyperShift docs. And what this is going to explain is basically like how all of this works. And so the idea is that HyperShift is a middleware for hosting OpenShift control planes. So things like the API server, the controller manager, all of the other operator bits and pieces necessary to operate OpenShift. You want to host all of those components as pods inside of some central cluster, right? So this is actually a little bit like, if you squint a little bit, it's a little bit like the EKS model, where EKS like spins up the control plane and manages that control plane for you. This is what that core, that standalone OpenShift cluster is going to do. It's going to manage the control plane of your clusters for you. And then you can join workers, bare metal nodes with GPUs. You could join VMs running on bare metal nodes. All of those things are available to you. You can run those VMs separate. But when I'm looking at it from the consumer perspective, the HyperShift cluster that I created, those workers are the only thing I'm going to see. I'm not going to be able to see the control plane. Now, if I go back to that centralized configuration, then I'll be able to see that control plane as a hosted control plane, right? But fundamentally, I'm just like running all of the components that make up the control plane for your cluster in some centralized cluster that we can easily secure and manage and handle the configuration within on that perspective. So to do that, though, that control plane needs to have it needs to have storage, it needs to have persistent storage, it needs to be able to be in a high availability mode, et cetera, et cetera. So that's kind of what I built. And I want to jump into a little bit more and kind of give you like an overview of what that is. So what I've got right now is I've got my storage all deployed. I've got KubeVirt as a virtualizer deployed. I've got all of those things running inside of this core cluster. Now, if I do kcli list VM, you can again see I just have those 4 VMs that have been created. So let's take a look at a params file for a HyperShift configuration. So my configuration here, I'm going to bring up 2 workers. I'm going to give each of my workers 16 CPUs, 16 gig of memory. I'm going to give them 80 gig disks, and I'm going to set network type to other. Although I could set it to Cilium. Let's do that. Well, let's leave it other, and we'll kind of go through that process. And then we have the slip equals true, and app users. We're just going to add the users app, which is the admin, and the default users that you can use in OpenShift. And these are all the parameters I'm actually going to specify for this, but there's a lot more that we could do, right? So if we wanted to see what we could do, right, we could do, again, that kcli info command, info cluster HyperShift. These are the default parameters that it will take if I don't specify anything else, right? So deploys a HyperShift cluster with an arbitrary number of workers. It relies on a valid kubeconfig and variable pointing to the cluster where a HyperShift operator is running. That's that multi-cluster engine component. Version can be latest, stable, WPU nightly, CI, or cluster, which means picking up the version from the cluster or from the top cluster. A mandatory default storage class is checked at the beginning of the workflow. Hypershift will also be installed on the management cluster if missing, either from the latest container. Now, I think there's some logic missing here because Hypershift is installed, but it still tries to check it. Auto signing of CSRs for workers is handled by a CROD job running in the top cluster in the dedicated namespace. Ingress IP is required for VERT platforms to provide a way to access apps from the outside. The VIP will be running through a dedicated kcli static pod. For deploying bare metal workers, bare metal hosts array needs to be configured. That means if you have a way to interact with bare metal workers, then you can actually specify those bare metal workers, including their out-of-band management configuration, and you can actually interact with them directly. Otherwise, you could create virtual machines for these things. You can set it to be assisted or KubeVirt. With Platform KubeVirt, the VMs will be created directly via the KubeVirt Hypershift integration in the hosted cluster namespace. With Platform Assisted, you would need to provision VMs via a preliminary step or use bare metal nodes and still define the bare metal array, or you can use the assisted VMs flags to have VMs provisioned for you. Okay. So let's go ahead and try this out. So if I do kcli create cluster hypershift dash param file shift.yaml, what this will do is it will create a shift cluster. It'll be called cluster shift, and it'll make sure that I have a default storage class. It'll use 122.252 as the ingress IP. It's going to use that slip stuff, so that's the domain that we're going to actually interact with. It's pulling down the RHCOS image. It's using Ignition to configure things. And again, it's like because of the way all of this is wired up, you can actually troubleshoot this, right? You can take a look at what's happening on the console. List VM. So no VMs yet. So created the node pool. Oh. There we go, starting to actually deploy some stuff. Looks like connectivity is being deployed on our behalf, which is very cool. We'll talk about why that's cool as we get further into it. Leveraging some of the cluster API work, creating the control plane operator, Kube API server. All of that's kind of getting deployed into that cluster. This is that hosted control plane we're talking about. So go to kubectl get hosted control planes. It'll be namespaced, of course. So let's look at all namespaces. You can see that the cluster that's being created is called Shift, and it's in the cluster namespace. YAML. So progressing, not done yet, but getting there. There's etcd operating, bunch of deployments, bunch of replica sets, bunch of other things. If I were to do this and move into the shift directory, again, what I've got here is a dremv, and I'm actually pointing at this, which I think might have changed the name. So ls kcli clusters. Yeah, I called it shift now. So I'm going to edit that. Dremv edit dot, change hypershift to shift. And if the kubectl exists, kubectl get pods -a. Not all the way up yet. We drop back a directory, then I'll get pods -n clusters shift -w. So this is the control plane. Things are spinning up. It's deployed the two VMs, shift worker 0, shift worker 1, which means we've gotten to the point where now at least we have reached the install state. Very, very cool. And now if I go back into my shift directory, kubectl get cluster operators. There we go. So now I can actually see this progressing. And this is looking at the cluster operators from the perspective of the control plane. So I can actually see that the Kube API server cluster operator is running and that it's in a true state. It's totally available. It's not degraded, right? I can also see the other components within the control plane operating inside of OpenShift. So it's not quite as opaque as EKS is because you have more of a view from the because of the information that is available from the operator perspective. But if I did kubectl get nodes on this hypershift cluster, there aren't any yet, right? The workers aren't up yet, and we're not going to be able to see the control plane nodes. But we are able to see all of these components. And just like we would expect, we wanted to take a look at the status of those nodes, right? You can do kcli console serial, and then I can actually take a look at the worker nodes. Looks like the worker node has already been booted up. And if I jump into that worker node, oops, shift worker 1, journal kernel, well, see things are booting up here. Create a new deployment. OS tree is doing its work, installing Podman. It's rebooting. You can watch it reboot. It is restarting. Very similar to the old CoreOS operating system model. There's two different boot trees, right? OS tree 0 and OS tree 1. That way, if one gets corrupted, you can kind of flip to the other. Watching the bootstrap process happen. Okay, we've reached the user space. We can SSH in to our terminal. You start seeing some kubelet node stuff happening. Doesn't have a certificate yet. So if I were to exit out of here again and I do kubectl get CSR, we should be able to see some pending certificates. And there is a cron job running right now. Kubectl get cron jobs -a. That's the image registry printer. We go back to the core cluster. This is the shift auto approver. It's running here. And then back into shift. Get CSR. Starting to see some approved issues. And this is basically just us adding those nodes back in, right? So by default, OpenShift takes a pretty reasonable stance of just not allowing any worker into the cluster without some previous permission. And what this cron job is doing is just basically saying, it's okay because we're going to be dynamically creating worker nodes, and we want to allow for those worker nodes to get brought into the cluster dynamically. So we should see those also become approved. Probably the next time this runs. And then we're going to see a different type of CSR request. So this is the client kubelet trying to authenticate, and then the next part will actually be the I can't remember the name of the signer. I like this tool. Basically, what this does is it uses the OC command to get all the CSRs in a watch, and it's outputting the range of items, if not status metadata equals n, and then passes the output of that to Xarc's ACM certificate approved. But I think actually that this won't work because of the if not status piece. So let's do this. There we go. So all the client certificates were approved. Now we're doing the kubelet serving one. This is a serving certificate for the same set. Okay. So now we should have all of our nodes up. Get nodes. We can see the two worker nodes are not available. But here's the thing: there's no CNI deployed, right? So if I do kubectl get pods -n -a, I should say. So we can see that like the connectivity agent is running. It's an API server shift. The API server proxy for shift worker and for shift worker 1 is running, but we don't have any CNI yet. We have Multis running, but no CNI yet. So let's talk a little bit about how to install Cilium here. Now that's an interesting one. I've actually used the other mechanism, so network type other, which means that I'm going to install my CNI myself after the cluster is up and running. So here is a way of understanding how the network is configured for this particular cluster. If I do oc get networks.config cluster-oyaml, this is the parameter. These are the parameters that can tell me basically how the cluster is currently configured, right? And again, we can see the network type has been set to other. We have a pod prefix of 10.129.0.0/14, and there's a 23 host prefix, which means that each node will get a /23 of that IP space to use for pod IPs. And if I look at my Cilium config, 07, 10.129.0.0/14, prefix mask 23, and then I'm actually just going to be using Cilium to deploy into this environment. In my configuration, I have set, I think, everything that needs to be set here. Oh, so in my configuration, in this configuration anyway, I'm setting this because I want the configuration to use a strict enforcement or a strict kube-proxy replacement mode. Before I can do that, I need to get rid of kube-proxy on the cluster. This will be an interesting one. How do we do that? Now, there is actually a way to do this. kubectl edit networks operator, not config. And I jump into that, and then here where it says deploy kube-proxy, I set this to false. And if I do kubectl get pods -n OpenShift kube-proxy -watch, we will see these turn from running to terminating. Now, unfortunately, nobody wrote the post hook cleanup for kube-proxy into this daemon set that they've created in OpenShift land. So while it will remove it, which is great, it won't actually clean up after it. And I'll show you what I mean. If I do kcli ssh shift worker 0 bash, oh, I don't know why I did that. Use the Docker. And I do sudo iptable save. All of this stuff, the kube service stuff, that's all from kube-proxy. That's kube-proxy configuring all of that. Now, if I remove kube-proxy, I'm going to need to remove all of that because it's going to mess things up. I do kubectl get ns grep proxy, still there. Kubectl get all dash n OpenShift kube proxy, and it's empty. So it's been uninstalled, but it hasn't been cleaned up. So at this point, what I can do is I can do kcli reset or restart VM, and then I want to restart the two workers. So shift worker 0 and shift worker 1. kcli VM lists. Nope, sorry, other way around. So those guys are rebooting. Console serial. And now that kubeproxy has been removed, we can proceed with the installation of Cilium. And then after this, we can also play around with scaling the number of worker nodes that we have in our cluster, just proving that out. The cluster's still up and interactable. It's just not got any workers at the moment because I've removed them to get rid of the kubeproxy piece. Okay, runtime, get nodes. You can see that they're in a not ready state. They're going to continue to be, but they're also not responding. Although kube worker 1 just responded. Okay. If I go back to my SSH again, and I do my iptables command again, you see that all of that kubeproxy stuff got kicked. It's not in here anymore. So that's good. I'm going to do kubectl config view. I'm pointing at 192.168.122.254. That is encoded in the certificate for this hosted control plane on the API servers themselves, right? So now what I want to do is I want to edit my Cilium config here to point at that part. There's two places I'm going to edit. I'm going to edit the overrides. (602). Make sure that's set correctly. 32758. Okay, that looks good. 32758. I'm also going to edit the Cilium config to point that at the piece here, and that's because we're going to be replacing kubeproxy directly. And so for that, because kubeproxy is a thing that actually ends up exposing 32758, because kubeproxy is a thing that actually exposes the way to interact with the API server, we need to kind of just make sure that we have another way to do that. So that's now configured. And if I go ahead and apply that stuff, apply-f or create-f, create-f, Cilium 115. All right, I'll get pods-n Cilium. We'll do a watch. Cilium OLM comes up and running. And then here in a second, we should see the OLM kick off the rest of the installation for Cilium. There she goes. Now we have our cluster coming up on Cilium. The Hubble UI is getting bootstrapped. Hubble Relay is getting bootstrapped. Cilium is getting bootstrapped. Take another look at the world. Looks like Envoy's up and running. The node's up and running. The agent is running on both of our nodes, waiting for Relay and UI to get deployed. There we go. So now, if I do kubectl exec ti-n Cilium, ps Cilium, bash, Cilium status, looks like cluster health 2.2, reachable, nothing is stopped, nothing is degraded, everything is okay, running in a strict kube proxy replacement mode. And if you do -- verbose, we can see even more information. Right, that's all of the controllers running. Reachable, reachable. Everything is working great. Yeah, and again, totally configurable, right? So scale, cluster, hypershift, shift, workers, 5. Well, 3. Let's do 3 workers instead of 2. Doesn't have a resource node pool. Info, cluster, hypershift. Yeah, I see that. Oh, what's this? Oh, that's fine. Well, no, that should have actually worked. Bim, shift.yaml. Let's change it here. Let's make this a 3. Do kcli, scale, cluster, hypershift. PF shift.yaml. Okay, so it found the 2 that I had. It found worker 0 and worker 1. It found that there was no configuration for shift worker 2. It merged the ignition data in and it applied worker 2. Now if I do kcli console serial for worker 2, we should see that guy bootstrapping. Doing some auto growing of file systems. Laying down all the ignition files. This will reboot once before we proceed. But we should see this become part of the cluster, just like last time. Super impressive work. There's shift worker 2. Get nodes -watch. There's shift worker 2. Wait, no, that's not the one. I want to look into the shift directory. So shift. There's shift worker 0 and shift worker 1. Here in a minute, after the reboot, we'll be able to see There we go. Pulling all the bits in. OS tree is working. Podman is doing stuff. Plug it away here, getting everything installed. So after it pulls down all of the necessary dependencies, it will do a reboot, and then we'll be able to see it join us up. And if you think about it, this is actually a very cool way of making it. This is the thing about Hypershift that I think is people are finding super compelling, is that it gives you the ability to dynamically create and destroy virtual machines, not just on the environment that we've got here, but also in, like, maybe I have multiple of these bare metal machines and I want to be able to create virtual machines on those bare metal machines and associate them dynamically with clusters that I've created with these hosted control planes, right? So it lets me make more efficient use of the underlying hardware than I would otherwise be able to make. Otherwise, I'd be like joining bare metal nodes to these hosted control planes, which might be my intent, right? Like if I'm actually running these things as like GPU nodes, for example, then that would be a great example of a reason why I might want to do that. Shift Worker 2 is rebooting. Hey, good to see you, Nuno. Welcome, welcome. I think you're really going to like this episode because it really points out a new tool that I've been super impressed with. And we have the author, I think, in the chat, Kareem B. But this tool is called kcli. kcli is a way of leveraging things like libvirt or overt or any of the other things out there to really kind of like bring up and manage different environments. Not just OpenShift, also QADM, K3S, Rancher, all this stuff. Just very, very cool. All right. So now I should be able to see that node get added. Here in a sec, I should see Shift Worker 2 show up. Here's 0 and 2, 0 and 1 talking to us. Yeah, next thing I want to try, I'm not going to do it on this episode, but I want to actually try handling an upgrade from one version to the next, see what that looks like. All right. Everything got deployed. It's completely installed. Our cluster is up and running. We're just waiting for that other worker to show up, but that shouldn't take too much longer. Yeah. Nino says, very nice. We'll have to look. Yeah, the WSL try would be neat. I'm not sure what the virtualization would be. The link is, let me actually share my docs. Give you 1 second here. There you go. That's where our notes are. And that note actually takes you to the repo. It takes you to the docs. It takes you to the Cilium integration within the docs. All of that stuff is there. Wow, this worker is really taking a minute to get booted up here. kcli SSH. Let's jump into that other worker. See what that looks like. VM list. List VM. It's always verb object, and I keep forgetting that. Oh, that's a domain. Journal kernel minus FL. Oh, you know what it is? Ha! Kernel get CSR. The pending. The pending. There is a what do you call it? A tool that will automatically approve this, but for our purposes, I'm just going to approve them. And that way we don't have to wait for them to get approved. Okay, kubectl get nodes. We should be able to see it now because it was just basically sitting there knocking at the door forever. Do one more approve stat. Now it's just installing Cilium. Wide watch. There's Cilium coming up on that new node. Away we go. Scalable architecture. If I wanted to add bare metal nodes to this, I could actually populate that bare metal array and go that route. Yeah. Well, that's what I wanted to share with you today. I think it's just an incredible tool for playing with and deploying different types of architectures. And also you learned a little bit about Hypershift and how Hypershift is actually kind of changing the game for all of this stuff, basically making it so that we can attach and create hosted control planes. Just really, really neat stuff. The highlight is hiding the console. Oh, I'm sorry. Yeah, that's true. I should have turned it off. Oh, Incus. Yeah, I played a bit with Incus as well. I honestly think like both of them are different mechanisms for managing things like VMs, containers, and that sort of stuff. I'm super impressed with this one. Like, as long as you can get libvirt running in this environment, then as long as you can get libvirt running inside of WSL2, which you may not be able to do. Maybe it's a different hypervisor. What is the different platforms? So there's kcli, host, info, host. Well, info profile. Let's go back to the docs. So the docs here, you can use as a hypervisor a bunch of different things. About. So you can use libvirt, vSphere, KubeVirt, AWS, Azure, GCP, IBM Cloud, Overt, OpenStack, Packet, and Proxmox. None of which I think actually operate inside of a WSL environment, but that doesn't mean that you couldn't use this tool to operate in AWS or in Azure or in GCP. You just wouldn't be able to run it locally with libvirt, I don't think. Unless you tell me that it does work, and I'll be super surprised. Anyway, I want to thank you for your time today. I know there's a lot that we covered today. I hope that you find it as interesting as I find it, especially this hypershift stuff that's really taken off, and I think it's a super interesting new opportunity there. Tune in with me next week, Nuno and others. Wednesday morning, eBPF.io. Join me for the eBPF Summit, where we are going to be presenting all things eBPF, not just from my team, but from folks around the world who are working on all of this stuff. Come join us. Come see the schedule. Come and be a part of it. You'll be able to see it live and interact with all of our amazing speakers live in the chat. I hope that you're going to be there, and I hope everybody will be there. So good to see you all, and we'll see you next time. Have the best weekend of your life.